All right, this week we're going to be talking about something called the mean absolute deviation. And we're also going to be looking at a data set and trying to predict what's going to happen on the next data set, or using a sample to try to predict what's going to happen on the with an overall group, a bigger group. And we'll talk more about what that means in a second. All we're doing when we find mean absolute deviation, for example in number 2, it's asking us, Paula's grades on her history test this semester are 79, 93, 92, 86, and 90. And we're going to skip number 1. I'm not going to give you a question like this, but it's asking what is the mean absolute deviation of her grades. All they're asking you to do there is to, first of all, you have to find the mean, and then we're going to see how far away each term or each number in the data set is away from that, and then average those. And what that does is, usually the smaller the mean absolute deviation, that means that the data is less variable. I mean, it's not all over the place. Whereas if you've got a guy who's got scores all over the place, that data is less predictable, has a smaller, what we call a variation, or a larger variation. That person's test scores are less consistent, less predictable, and so on. So let's go ahead and find, first of all, we have to find the mean in order to find the mean absolute deviation. Well, of course, in order to find the mean, we have to add the 1, 2, 3, 4, 5 scores up and divide by 5. So let's do that now. We've got a 79, a 93, a 92, 86, and a 90. And we're going to take our time and add these up. That's going to be 12, 14, 20, 0, it's 20, carry our 2, 18, 27, 36 plus 8 is 44. So we got a sum of 440, and of course we're going to divide that by 5 to get our mean. So we got 4, 4, 0, this is going to be 8, 40, with a remainder of 4. This is going to go in here 88 times, or 8 times for a mean of 88. And I'm just going to check my work on my calculator here. 79 plus 93 plus 92 plus 86 plus 90. '79 plus 93 plus 92 plus 86 plus 90 divided by 5 for an 88. Now what you have to do is find the difference. And when we subtract, we're going to find the absolute value. But all you need to do is find the difference. And difference is always positive between the 88 and all these numbers. You're going to find the difference between those, and then you're going to divide that number by 5. Okay? We're going to divide that number by 5. So what is the difference between 88, and we know our mean is 88, so I'm going to mark it up here and just erase all this other mess. The difference between 88 and 79, normally we would just take the big number and subtract the small number. And we can do that, but for the sake of time, we'll just go ahead and do this one real fast. Minus 79, we're going to end up with 9. So 9 is one of our terms. Okay. The difference between 88 and 93 is 5. The difference between 88 and 92 is 4. The difference between 88 and 86 is 2. The difference between 88 and 90 is 2. And now we're simply going to add these numbers up and divide by 5 to see what the absolute mean deviation is. And that's all that, or sorry, the mean absolute deviation. Forgive me. So 9 plus 5 is 14, plus 8 is 18, which is 20 and 22. Then we're simply going to divide that by 5. And I'm running out of room here, but you'll get the point here. This is going to go in here 4 times. Remainder of 2. Carry a decimal point up. 5 will go into 24 times. That's a 4.4. Forgive my writing, and the answer is C. So remember, all we do is find out the mean find out the differences between that mean and all the numbers in the data set, add those up, divide it by the number, which is 5, and then it gives you your mean absolute deviation. And again, if you have a very consistent data set, in other words, pretend these are, again, grades like we have here, the closer they are together, the more consistent that person is. The more drawn out and the larger the mean absolute deviation, the less predictable, the less constant that data is going to be. In other words, the data is all over the place, like we talked about in class. Same as with our box and whisker plot. You remember if we had a box and whisker plot where the box and whisker plot was really, really big, and the interquartile range was really, really big, the range was really, really big, that meant that data was less consistent all over the place. We couldn't really predict what that person was going to do. Okay. All right, moving on. The lengths in seconds of 4 folk songs are the data we have here, and then the lengths in seconds of 4 pop songs. We're talking about folk songs and pop songs. What is the mean absolute deviation in seconds of the folk songs? Remember, what we would do here is simply add these up for the folk songs, divide by 5 to see what our mean is, and then find out what the difference between the mean and all these different numbers were. Okay? Add those up and divide by 5. We would do the same thing here, and it's going to ask you to compare those. It's going to ask you to compare those. Okay? And then later on, like we had before, if it says compare the mean to the mode, well, you might say the mean is 2 points higher than the mode. They're going to ask you to do the same thing here. Which of the following statements is true? Okay, and then they'll ask you, when you're looking at the two numbers, help me compare the two. The variability in the times of the folk songs is about half that of the pop songs. You're going to have to take your time, read these questions, and make sure you can actually compare those two deviations. And again, we have the same things here. I'm not going to keep doing these, but you need to know, again, that the bigger the mean absolute deviation is, the more inconsistent, the least predictable or less predictable the data set is. And here we're going to do the same thing with a dot plot. What is the mean absolute deviation in minutes of the lengths of each group's practice? All right, so we're going to have to find the mean absolute deviation for both. All right, so we're going to start with the band, then we're going to go on to orchestra. Now you can look, and you can kind of tell that most of this data is centered around here. So you can kind of visualize this and say, hey, look, this data is going to be more consistent. This is going to be more spread out. But let's go ahead and test the theory. All right. Again, you can look at this. Most of this data is 35 and 40. This is very crunched together, very, very predictable. Whereas on the other, the band is very, very, kind of all over the place. Well, let's go ahead, and since we have a visual of this and we can see that, let's go ahead and test and see what our mean absolute deviation is and see if we can prove our theory right. So let's go ahead and talk about band. The mean absolute deviation of the band and the mean absolute deviation of the orchestra. Okay? So we've got 25. We're starting with the band. We got 35. We've got 40. Don't forget there are two 40s. And then we've got a 50. Let's see, it's 5, 10, carry my 1. I got 3, 6, 10, 14, 19. 190. I got to find the mean, so I'm going to divide by 5. So 190 divided by 5. I hope you can see this well. If I would go into 19 3 times without going over, this is 15, 4, 0, 8. So my mean is 38. My mean is 38. So I'm going to put that right here. My mean is 38. Now I'm going to find the mean absolute deviation. So I'm going to find the difference between 38 and 25, 35, 40, 40, and 50. So the difference between 38 and 25 is 13. Here is 3. The difference between these two 40s and that is 2 and 2. And then we have a difference between 50 and 38 is 12. And again, you may have to write that out on your paper. No shame in that. You may have to take your time and do that. So you're going to add these differences up and then again divide by 5. 6, 7, 8, 9, 10, 11, 12. Carry my 1. And I've got 1, 2, 3, 32. And then we're going to divide that by 5. Say 5, 32. Go ahead and put us a few decimals out here because I know it's not going to go perfectly. Let's see, 6, 32, bring down, it's going to be 6.4. So for the band, it's 6.4. Let me go ahead and check my math again to make sure I'm correct. I've got a difference between, that's 13, a difference of 3, a difference of 2, a difference of 2, a difference of 12. Let's see, 13, 14, 15, 16, 17, 18, 19, 20, 32. All right. So the mean absolute deviation for the band is 6.4. Let's go ahead and find it for the orchestra. We know the mean there is that, so we're going to leave that up there. Let's go ahead and move over here and find the mean. So I got 35, 35, 40, 40, 40, 0, 1, 4, 5, 6, 7, plus 12 is 19. So it looks like we're going to have the mean be the same, 190. We just had 190 a while ago. So I know if I divide that by 5, the mean here is going to be 38. Okay? So let's get rid of these guys. And then ask ourselves, how far away is the mean from each one of these? Well, I've got 3, 3, and then 2, 2, and 2. I add those up, that's 6, 7, 8, 9, 10, 11, 12. And then I'm going to divide by 5, of course. So I've got 12 divided by 5. I'm sorry, forgive me, I know it's hard to see. I got a decimal here. I'm going to bring that dude up. That's going to go in here twice. I got 10, a remainder of 2. Bring down my 0. That's going to go in there 4 times. So I have a mean absolute deviation of 2.4. Okay. How does the variability in the lengths of the band's practices compare to the variability in the lengths of the orchestra practices? Explain your thinking. Again, the band has a bigger variation. You can visualize that here, but you can also find that mean absolute deviation of 6.4. The higher it is, the more variable it is. The less predictable it is, the less constant it is. Whereas we have a mean absolute deviation of 2.4 here, which means that our data is more predictable, it is closer together, it is more consistent. Okay. Now, let's move on to predictions. And predictions to me is the easiest part. All you really got to do is just find the mean, median, and mode, or whatever they're asking you, and you can use that to make predictions about what's going to happen. Okay. So let's go ahead and close that guy out. Making predictions. Okay. And you're going to see how simple this is. This is probably one of the easiest sections in this unit. And let me just blow this screen up just a touch. Let's blow it up to about 200%. That way we can see it just a touch better. The heights of 5 pepper plants in centimeters were selected at random from a greenhouse. And remember that at random, that basically means that's going to the best of our knowledge, it's going to best represent the data. From a greenhouse with 50 pepper plants are shown below. So we've got a 20, a 24, an 18, a 23, and a 26, which is a reasonable prediction of the mean height of all the pepper plants in the nursery. So we want to say, look, we've pulled 5 out of the 50. The best thing for us to do is just to find the mean of this group and see, hopefully that will be a good predictor, or probably the best predictor of what's going to happen with all 50. So all we need to do is add these up and divide by 5, find the mean. Okay. Now if we had talked about the mode, it might be a little bit different, but we're talking about the mean here. We're going to add that up and divide by 5. So we've got I'll add them up over here. 20, 24, 18, 23, and 26. For a total of 4, that's 12, 15, 21, carry my 2, 4, 6, 7, 8, 9, 10, 11, 111. Okay, I'm going to divide that by 5, and let's see. 111 divided by 5. I'm going to go ahead and put a decimal out here. It's going to go in there twice. That's a 10, 1. That's 2. That's 10 again with a 1. Bring down my 0. 22.2. Well, Mr. Camp, there's not a 22.2 down there. Well, why don't you just go with the closest number, because it's not going to be exact. So it's giving you 4 choices here. Which one of these is closest to that? Of course, it's going to be B. Okay? They're not going to be exact all the time when we're trying to make predictions. Okay? A city is having a cleanup day for the 25 parks in the city. The list below shows the ages of volunteers participating in the cleanup project at one of the parks. So we got all these different ages. Which is a reasonable prediction of the mean age of all the participants in the cleanup project? I'm not going to work this one out. You're going to do this one the same way. You're going to add those up, divide by 1, 2, 3, 4, 5, 6, 7. Whichever one's closest is the one you're going to choose. Enid reads the following numbers of pages each day. So one day she'll read 76, the next day she'll read 123, and so on. Which is a reasonable prediction of the mean number of pages she reads each day throughout the year? Again, you're going to add these up, divide by 1, 2, 3, 4, 5, 6, 7. Get the number that's closest to these choices. We're trying to use this information to make a reasonable prediction of what's going to happen in the future. If the past is any indicator of the future, that's what we're doing here. Vincent stood by the log flume at an amusement park and asked 120 people exiting the ride to name their favorite ride. The table below shows the results of the survey. So keep in mind, he was standing at the log flume. Okay? And he asked those people what their favorite ride was. And we have 25 said the roller coaster, 22 said the Ferris wheel, 58 said the log flume, and 15 said the carousel. Which of the following is the most reasonable prediction based on the survey? A, the results of the survey that show the log flume is the favorite ride are biased because only log flume riders were surveyed. I think that might be a reasonable choice. Keep in mind, we talked about this a couple weeks ago. If you wanted to find out somebody's favorite ride, you're not going to stand by that by one ride and find out, because chances are people are already at their favorite ride. So I think A may be a good choice, but let's go ahead and read them all. The results of the survey show that the log flume is the favorite ride are reasonable. I don't think so, again, for the reasons I stated earlier. The results of the survey, C, show that the log flume is the favorite ride are unreasonable because the number of people surveyed was too small. I think our survey size is good. So he's right that they're unreasonable, but not because of the reasons they said there, because the survey size, I think, is adequate. If you had asked 5 people, that might be a good answer. D, the results of the survey show that the roller coaster is the favorite ride are unbiased results. That means that they are good results, and I think that is not the good choice. I think our choice, or I know our choice, is choice A. Carla runs for exercise several times each week. The number of miles she ran for each week for the last 6 weeks are shown below, which is a reasonable prediction of the mean number of miles Carla runs each week throughout the year. So we're saying, we've got these 1, 2, 3, 4, 5, 6 different times she runs. We want to see if we can use that to predict what she'll run all year. And we'll go ahead and work this one out. We'll add them up over here on the column. We say 10 and 9 and 8 and 14, and 9, and 12. Let's see, we got 17, 18, 19, 20, 21, 30, and 32. Carry our 3, 4, 5, 6. We got 62 out of 1, 2, 3, 4, 5, 6. So we're going to divide by 6. Do it over here. 6, 62. We're going to go ahead and we know we're probably going to end up with a decimal here because we know that's not going to go. 6, 0, 2. That's 0, 0, remainder 2. Bring down our 0. Go about 3 times. Now I could keep going if I wanted to, because I think we're going to end up getting a very, very long answer. But can't we go ahead and make a reasonable decision that she's probably going to run about 10 minutes? Or sorry, 10 miles. Number 6 is very, very similar. Middle school students in a school district are collecting books to share with sister schools in Africa. The table shows a number of books that students at Lincoln Middle School collected for 5 months. All right, so it looks like we're going to try to use the 5 months to predict what would happen over the course of the year. What is a reasonable prediction of the mean number of books that students at Lincoln Middle School will collect each month throughout the year? Explain your thinking. And I'm not going to take the time to add all these up and divide by 5, but basically you would do that, get a mean, and that number would predict what would happen throughout the year. What is a reasonable prediction of the mean number of books collected each month by the students at each middle school in the school district? Explain your thinking. I'm not going to do this, so I'm going to leave it here. But basically, again, we're taking sample data or a small portion of the data and trying to make predictions with it.